Good morning, grade 10s. I hope you guys are all well and that you are keeping safe and keeping healthy. We are missing you guys and we are looking forward to seeing you soon. But in the meantime, please make sure that you are keeping up to date with your work. Please make sure that you are doing a little bit every day and that you are doing your activities and marking your work with the memos. On Monday and Tuesday this week, we did the hyperbola. We learned how to draw a hyperbola and we learned how to find the equation of a hyperbola. For the rest of the week, as well as a few days next week, we are going to be focusing on the exponential function. You will see the standard form of the exponential function is y is equal to a times b to the power of x plus q. Now the first thing you should notice is that your exponent is the x, and that's how you know you are looking at the exponential function. In the previous ones that we've done, you've had things like x squared or 2x, but in this case it's to the power of x, so that indicates to you that it is an exponential function. You would see that there is an a and a q, which you should be familiar with. The a determines your steepness of the graph and your q is your vertical shift, but I'll look at those in a few minutes. And something new that you will notice is now the value of b, where the value of b determines the position of the graph. And it's very simple, but it's just something that you need to learn, and I'm going to elaborate on that in a few seconds. Looking at the effect of b, you will see on the slide I have drawn a Cartesian plane. In your first quadrant, if your b value is positive and bigger than 1, your exponential graph will increase going into quadrant 1. If you look at quadrant 2, it's also a positive exponential function, but the difference between quadrant 1 and quadrant 2 is that in quadrant 2 your b value is a decimal that falls between 0 and 1. So it would be a fraction like a half, a third, a quarter, or 0.32. All of those would fall into the second quadrant. So when your b value is greater than 0 but smaller than 1, the graph falls into the second quadrant. Then if your graph is negative, so if your b value is negative and if your b value is a decimal between 0 and 1, so a negative fraction in other words, your graph will fall into the third quadrant. And the fourth quadrant, if your graph is negative but your b value is greater or equal to 1, so it's not a fraction, it's greater or equal to 1, it's negative, it falls into the fourth quadrant. So you will see the first and second quadrants are when your graphs are positive. The third and fourth quadrants are when your graph is negative. You will see that the first and fourth quadrant is if your b value is equal to or greater than 0. So it's not a fraction, it's a number greater than 1. And you will see that quadrant 2 and quadrant 3 is if your b value falls between 0 and 1. So it is a fraction between 0 and 1. You will see the effect of a is very similar to your hyperbola and your linear and your parabola. The effect of a determines the steepness of the graph. So with the exponential graph, the steeper the graph is, the closer it will be to the y-axis. It will go closer and closer the steeper it is. The a value for the exponential graph also determines the y-intercept. So if you've got the function y is equal to 2 to the power of x, your y-intercept is 0 and 1. If you've got y is equal to 2 times 2 to the power of x, you can see your y-intercept becomes 0 and 2. If you've got y is equal to 3 times 2 to the power of x, your y-intercept is 0 and 3. And for example, if you had y to the power of 10 times 2 to the power of x, your y-intercept would be 0 and 10. So that a value will determine your y-intercept. And lastly, the effect of q is exactly the same as your hyperbola and your parabola. The q determines how many places the graph shifts up or down. So if your q value is plus 4, it means that the graph has shifted up 4 spaces compared to the original. If your q value is minus 3, it means the graph has shifted down 3 places compared to the original. And same as our hyperbola, the Q value determines your horizontal asymptote. So remember, an asymptote is a line that the graph will get really close to but will never touch. So for example, in the function y is equal to 2 to the power of x plus 3, that plus 3 is your Q value, and it shows you that the graph has shifted up 3 spaces, which means the equation of your asymptote is y is equal to 3. So at y is equal to 3, you would draw a dotted line, you would label it y is equal to 3, and you would know that the graph will get really close to that line, but it will never cut that line. So that is the effect of Q, very similar to a hyperbola. I'm going to do some examples with you so you can see. The first one is y is equal to 5 to the power of x. The second one, I've added an a value in, so I've said y is equal to 2 times the power of 5, 2 times 5 to the power of x. So my a value there is 2. And then for the third one, I've gone one step further and I've added a q value. So you can see y is equal to 2 times 5 to the power of x plus 3. So I just want you to identify what value is which. So for the first one, you can see that your b value is 5. I want you to just note a few things. Firstly, 5 is positive, so we're looking at either the first or second quadrant. And secondly, you can see that the number 5 is greater than 1, so we're looking at the first quadrant. Then if you look at the second graph, we've already established that 5 is in the first quadrant. And then you can see I've got 2 times 5 to the power of x. So that 2 is my a value, which means my graph is going to be steeper than what the first one would be. And then for the third one, you can see I've added in a vertical shift of plus 3. So my q value is plus 3. So you should see that your asymptote is going to be at positive 3. So y is equal to 3. And you should see that when we draw the graph, it should shift up 3 spaces. So please make sure that when you get the equation of the exponential graph, you have to draw that you identify which is your a, which is your b, and which is your q value. Right, grade 10, so you can see that I'm going to sketch the 3 graphs. The first one, y to the power of 5x, second y is equal to 2 times 5 to the power of x, and third one, y is equal to 2 times 5 to the power of x plus 3. I'm using the table method, as you can see, and my input values, I've got negative 1, 0, and 1. And I'm going to use my calculator to find these values. You should by now know how to do that, so I'm going to type in my function, f of x is equal to 5, my exponent button, alpha x is equal to, my starting point is going to be negative 1, ending point positive 1, and my steps I'm going to go in intervals of 1. I'm going to plot those points. So at negative 1 I've got 0, 2, 0 I've got 1, and at 1 I've got 5. So those are my 3 coordinates. So what I'm going to do is I'm going to actually draw the graph first, and then we'll carry on with the next ones. So for the first one, I've got negative 1 and 0, 2. So 0, 2, if that's 0, 5, 0, 2 would be about there. I've then got 0 and 1, which is there. And I've got 1 and 5, which is there. So I've got those 3 points. And from there, I'm going to join them, make a nice curve. And you can see that the graph will get really close to the x-axis but will never touch. Moving on to the second graph. So I'm going to type it in. I've got 2. Don't do point. You need to do times. 5, the exponent button, alpha x. My starting point, negative 1, ending point 1, and my intervals are 1. So it's going to be negative 1 and 0, 4. It's going to be 0 and 2, and it's going to be 1 and 10. So I'm going to plot those points. It's important to remember you're using the times button, not the dot. So I've got negative 1 and 0, 4. So if 0, 5 is there, it's just below. I've got 0 and 2, which is there. Remember, your a value affects your y-intercept. and then you've got 1 and 10, so 1 and 10 would be about there. And then I'm going to plot those points. So remember, your A value affects the steepness of your graph, and it affects your y-intercept. So you can see there the graph is quite a bit steeper, it's getting closer to the y-axis, and you can see your y-intercept has jumped up 1 place to 2. And then the third one, I'm going to put in my equation. So I've got 2 times 5, the exponent button, alpha x to the side, and plus 3. That plus 3 should already indicate that you've got a vertical shift. So my starting point is -1, ending point is 1, and my intervals are 1. So I've got -1 and 3, 4. I've got 0 and 5. Sorry, 0 and 5. And I've got 1 and 13. Okay, so before I even draw my third graph, I'm going to put in my asymptote at +3, because my graph has shifted up 3 places. So it's just a dotted line, and you would label it y is equal to 3. And then you're going to plot your points. So you've got -1 and 3.4, so 3.5 would be about there, so 3.4 is just below it. You've got 0 and 5, which is there, and you've got 1 and 13, which is there. Yours would obviously be more accurate than mine. And I've got my 3 points. Now I'm going to join them. And you can see the graph will get close to your asymptote, but will never touch it. Okay, and then once you've done that, you can label it. So this one here is y is equal to 2 times 5x plus 3. This one over here is y is equal to 2 times 5 to the power of x. And then this was the original, y is equal to 5 to the power of x. So what I want you guys to see here is that I'm using the table method. My input values are -1, 0, and 1. And then just notice the effect of the A, the B, and the Q value. The A value indicates your y-intercept. It also makes the graph steeper if your A value is greater. The B value determines which quadrant your graph is going to increase. You can see that the B value is 5. So 5 is greater than 1, yes, and it's positive, so it falls in our first quadrant. And then the Q value shifts my graph up 3 places. I indicate it with the asymptote, y is equal to 3, and it shifts up my whole graph 3 spaces. Okay, grade 10s, I hope those examples helped you. You would have noticed in the examples that I've used the table method for all 3. You are going to do the same for the homework for the next couple of days, but please, I want you to include your asymptote as well as your y-intercept. You are going to indicate those, but you are going to basically use your table method to draw the following graphs. So for today, you're going to first of all go through your notes, which I'm sure you've done by now, then watch the video, which you've already done, and then you're going to do exercise 15. For Thursday and Friday, there is no video, but on Thursday you will see that we're going to explore the effect of A in a bit more detail, and then you're going to do exercise 16. And then on Friday, you will see we are going to explore the effect of Q, and then do exercise 17. So just a reminder, for Thursday and Friday there is no video, but you are going to go through the notes and then you're going to do the exercise. The video for today covers the content for Wednesday, Thursday and Friday. Alright, grade 10s, I hope you enjoy the rest of your week. I hope you have a great weekend. We are looking forward to seeing you guys soon. Please, if you're stuck with anything, if there's something you don't understand, your teachers are literally waiting for you to ask questions, so please do not be shy to contact them. Thanks, grade 10s. Have a good day. Cheers. Bye.